Hello friends, welcome to another video. Today we are going to learn about source transformation, second video, where we actually solve problems using source transformation. So previously we have shown you that if you have a voltage source and a series resistance, this is V, this is R, that can be equivalent to a current source and a parallel resistance R, okay, and vice versa. So this was the plain source transformation. This was source transformation what we did, and this I was simply V over R, and we have done. So we already told you about this, and today we are going to see that what will be the actual problem solving situation. Okay, so let us start with a very simple and basic problem. So you can see that this particular problem, there are actually many source and we need to calculate in this problem. Our aim is to calculate the current through this 7 ohm resistance, and the current through the 7 ohm resistance is given by I0. So that is the current we need to calculate. Frankly speaking, there are several ways to do, but particular this problem, but for this kind of problem where you have some elements on the right hand side of the target resistance, I call this a target resistance, across which voltage drop as well as the current to be calculated. So particular this problem, we can convert all the sources into current source, and then we can show that then we will come to a point where all are connected in parallel, and then we can actually swap between the resistances and the sources. So without doing any further introduction, let us start. So let's say this particular equation is equation number the circuit number 1. So we need to transform this. Now you can look at this particular two resistances are connected in series, so we can directly convert them into you can add them up into 1 plus 4 5, and this can be this 3 and 6, they're actually, so this 3 and so this 6 resistance, 6 ohm resistance and 3 ohm resistance, we can swap them and we can get another circuit because they are connected in parallel. So this particular terminal, this particular terminal, this particular terminal and this particular terminal, they are actually same, and this and this, they are actually same. So these three elements, this element and this element, they are connected in parallel, so they can be swapped. So we can write down pretty easily. So the current source come on the left, and 6 ohm, then we have 3 ohm, so we connect them. Then this 5 volt source, and then the target source, and which is I0 going through it, and then we have another current source which is 3 ampere, and then we add up these two resistances as 5 ohm. Okay, so this is our second circuit. So this is pretty easy, though these two just we have calculated. Now you can think of that this this 6 and 3 they are connected in parallel, so we can calculate that this is, so here the R equivalent is 1 plus 4 ohm equal to 5 ohm, that we have calculated here. But what about this 6 and 3? So 6 and 3 equivalent is 1 by, let's say this is R1, let's say we can say, and this is say R2. So 1 over 6 plus 1 over 3, which given by 1 over R2 is given by 6, which is 1 plus 2, and which is 3 by 6, which implies R2 equal to 2. Okay, so R2 equal to 2. So we can go to our, so the third circuit we can write it as, so you have a current source and then you have a resistance. So what is the current source? Current source was 5 ampere. So this is 5 ampere, this is 2 ohm, then you have a 5 volt source here, and then you have the target same resistance through which I0 current is flowing, and you have another current source and another parallel resistance, so which is actually 5 ohm, right? So you need to be a bit more cleaner because I am writing. So yeah, so now you can see that this particular 5 ampere source and 2 ohm resistance, they are connected in parallel, and so we can convert it into voltage source and a series resistance. So for 4 we can have that, so we can have voltage source, as this is from down to top, so the polarity of the voltage source will be like this. Then you have a series resistance, so which is of course 2, and the voltage will be 5 times 2 equal to 10 volts, and there will be another voltage source which is connected in series, and then the target resistance 7 ohm, the 3 ampere current source, and the 5 ohm resistance. So they are connected by a line, so by a voltage, like a resistance less wires, ideally speaking. Now you can say that these two batteries are connected in series, just like a flashlight. So they are connected in series. So, and you can see this plus minus minus plus. So minus plus minus plus, that means they are connected in series. So that means we can add the voltages up. So the equation number 5 will be, so we can write down as, so there will be a voltage source of 15 volts, and then a series, so series connected here. So there will be one series connected resistance, and then the target resistance 7 ohm, then another 3 ampere here, and another 5 ohm resistance here. So this is 5 ohm, correct? So this is 5 ohm. Now you can see that still we are not done yet. So these two, this is I0 we need to calculate. So equation number 6 can be written as, so these two, this 15, this 2 ohm, this 2 ohm resistance, this 2 ohm resistance and this 15 volt source, they can be made as a current source they can be made as a current source of 15 by 2 ampere value, and then you have a series resistance of 2 ohm, then the target resistance 7 ohm, and then the current source of 3 ampere, and then the final 5 ampere resistance, okay, 5 ohm resistance. Okay, this is the 6th circuit. Okay, so let us go to the next page. So this 15 by 2, so this 15 by 2 comes as 7.5 ampere. So in the next page we can write down in a bit of fair mode, in a very better understanding. So that this is actually your 7.5 ampere, and this is, sorry, so there will be a parallel resistance. So you can have a parallel resistance of 2 ohm. So 2 ohm, then the target resistance 7 ohm I0, and then 3 ampere, and then 5. Okay. Now you can see that now this is parallel circuit. This is actually a parallel circuit. So number 8. So this is parallel. So all terminals what you see here, they are connected at the same terminal. So they are actually connected in parallel. So we can actually swap between any two elements. Okay. So therefore we can easily reframe the circuit as, so we can write as, this is 7.5 ampere, then 3 ampere, then 2 ohm, then 5 ohm, and then 7 ohm. Okay. So now you do not touch this 7 ohm resistance, and we do not do any transformation on 7 ohm, because the target source cannot be touched. Okay, so let me redraw a bit a better way. Yeah, so this is 3 ampere, right? So we are not touching this source, we are not touching this one as a whole, because we are just going from one way to the other. Now these two are current source, they are also pointing in the same direction, so they add up to a current source of I equal to 7.5 plus 3 ampere equal to 10.5 ampere, right? And this particular these two, 5 and 2, they are connected in series parallel, and then the equivalent resistance is 1 by 2 plus 1 by 5 equal to 10, and 5 plus 2, so 7 by 10, which is given by R3 equal to 10 over 7. Okay, so the ninth circuit will be a current source having 10.5 ampere of current, then a parallel resistance of 10 over 7 ohm, and then another resistance of 7 ohm. So I told you in the previous and this should be I0. So I told you that you can only apply Ohm's law up to and unless you have only single voltage source and several resistances, right? But there are current source available, so we cannot do any kind of transformation here. So in the next page we can still do this. This will be 10th, right? Yeah. So we can still write. So this is your current source having 10.5 ampere of current. Then another current source of 10 over 7, and this is this is resistance, and this is also 7 ohm. So and they are connected in some wire. This is I0. Now this still we cannot do. You can have a current distribution law, but we cannot apply. So what we have to do, so these two, they are connected in parallel, so they can produce one voltage source having voltage of V equal to 10.5 times 10 over 7 resistance, and then you have 10 over 7 ohm in series, 10 over 7 ohm in series, and then this 7 ohm, right? I0, this is 7 ohm, correct? So this is the value. Now we have to simplify this. We cannot simply make through like that way. So what will be the value of this? So let us calculate this is 7 by 10 by 7. 10 divided by 7 is nothing but 10 divided by 7 is 1.43. So 1.43 times 10.5, so it is 15 here. So it is given by 15 here, and this is given by 1.43 ohm. Okay, 1.43 here. So this is volt. So now in this circuit we can actually calculate the current. So this is a single loop, and I0 is actually the current. So the I0 will be given by 15 divided by 1.43 plus 7 ampere. So we know that it should be 15 by 18.43 ampere. Okay, 8.43, right? So let us calculate that. So 15, let's say 15 divided by 8.43, which is given by 1.78. So which is given by 1.78 ampere, and that's the answer. So we can cross verify. You can also cross verify by any other source, but this is the answer. This is the final answer of this equation of this question. So this is something we need to do, and hopefully you could have understood that. So let us do another problem, another simple problem of the same kind of source transformation. So here also the same thing, we need to calculate this, current through this I1. So this is circuit number 1. So same thing, you have some portion of this circuit having some elements on the right hand side, some elements on the left hand side. So you need to prepare one circuit which has only you need to keep on converting into current sources and parallel resistances and parallel current sources, so that we can have. So what is the strategy? We can keep on doing that. So let's say the equation number 2. So first of all, we need to transform this current source and resistance into a voltage source and a series resistance. So let us draw. So this is plus minus 10 volts. I am not doing any other thing. So this is it, and this is the, so this is 5 ohm, this is 5 ohm, this is I1, so which is not to be touched. Okay. Now this C terminal and it, so this is actually C terminal. Okay, so we have came across this part, so we can write down. So this is, so 1 ampere voltage and 1 ampere current source with a 10 ohm resistance in parallel will be 10 ohm resistance in parallel, and a voltage source, as the current source is from right to left, it should be also right to left, and then the value will be 1 multiplied by 10, because V equal to IR. So I equal to 1 and R equal to 10. So V equal to IR means 1 multiplied by 10. So it should be 10 volt, and then the other resistance, which is 5 ohm, right? They are connected. Okay. So now you can find out. Now you can simply see that. So this is your, now I told you that you need to convert this. So let us simplify this first, then we talk. So this is 5 ohm, this is 10 volt, then the target resistance of 5 ohm, this is I1, and this is, so this 10 ohm and 5 ohm, they are connected in series, so they together gives you 15 ohm, and the voltage source having plus minus 10 volts. Okay. So now these two, I told you that you have to first convert them into current source. When you have some element on the left hand side, some element on the right hand side of the target resistance through which current is to be calculated. Now how we do that? So let us go into the fourth circuit as, so we can convert this voltage and resistance into current source and parallel resistance. So it should be a current source from down to top, and it should be like 10 divided by 5, because V equal to IR. So it should be 2 ampere and 5 ohm resistance in parallel, then the target resistance, and then same thing. So it should be like, it should be 15 ohm in parallel, and then you get 10 over 15 ampere in parallel. So this is will be your circuit. Okay, and this is the target one. So this is I1. Okay, so this is something you got. So let us simplify. So 10 over 15 is nothing but, so 10 over 15 is 2/3. It is 2/3. It is actually 0.67, right? So let us have another circuit here. So equation number 5. So you have a current source of 2 ampere, then 5 ohm resistance here, then the target resistance of 5 ohm, this is I1, and then you have another current source. You have then a resistance. You have a resistance here. You have a resistance here as 15 ohm. You have a resistance here as 15 ohm, and then you have a current source. You have a current source of 0.67 ampere. Okay, so you complete this circuit, right? Now you know that now this is the same thing. You have to swap the voltage source and the resistances to each other. Then the sixth circuit you have here, you can skip one step, because this 2 ampere and 0.67 they are actually pointing towards top, or let us not skip the step, so that might give you a problem. So 2 ampere, then 2 ampere, then 0.67 ampere, then 5 ohm, then 15 ohm, then your target 5 ohm, which carries current I, okay, which carries a current I1, right. So this is something you have. Now these two adds up, these two are connected in parallel. So let us say that I current of this two current source is 2 plus 0.67 equal to 2.67. Now these two has a resistance of, let's say, R, and which is given by 1 by 5 plus 1 by 15. So this is 15, and 3 plus 1 equal to like 4 by 15. So R equal to 15 by 4, which is given by 3.75 ohm, right. 3 4s are 12, and we get 3, and then 3.57. So ultimately the seventh circuit we can write as 2.67 in circuit, then you have a 3.75 ohm as resistance, then you have another target resistance of 5 ohm, and which is connected to each other, right? This is the seventh equation. Now again I told that you have to convert it into only one loop having one voltage source and several current source. So let us write down let us have the simpler circuit as, so 2.67 volt, sorry, 2.67 ampere current, then you have 3.75 ohm, and then you have the target resistance of I1. So they are all connected in parallel. Now these two, now these two, they are connected in parallel, so you can convert this into a voltage source and a series resistance. So voltage source, it will be plus minus because it is, so the voltage source should have a voltage of 2.67 times 3.75, and there will be a series resistance of 3.75, and then you have the target resistance of 5 ohm, and you are actually done. So what is the value of 2.67 and 3.75? It is actually 2.67 times, sorry, 2.67 times 3.75 is given by 10.0125. So I will keep up to second decimal place to 10.01. So yeah, so we can get 10.01, which is the volt. Now you can simply say that I1 is nothing but the current flowing through this circuit. So I1 will be equal to 10.01 divided by 3.75 plus 5 ampere, and which is 10.01 divided by 8.75 ampere. So let us calculate that, and which is actually 10.001 slash 8.75, which is given by 1.144 or simply 1.14 ampere. So this is how you can actually do, and for your own exercise you can see another circuit. So you can find out how to get this one done. So for another part, so this is the third circuit we are going into going to analyze. Here things are same thing, like we have to calculate the V0 across this voltage across the resistance 100 ohms. So the same procedure we will follow. So what will happen is that we can, so this problem number 3. So the second circuit will be, so this one we can, I told you that if you have left hand side and right hand side both you have some element, then keep on converting into current sources connected in parallel and having resistances also in parallel, so that will be easier for you. Okay, so here these two can be converted into a current source, and what is the current source value? So it should be like, so V equal to IR, so the current source should be 10 divided by 100, V equal to IR, so it should be 10 divided by 100 means 0.1 ampere of current, and there is a 100 ohm resistance connected in parallel, then another 100 ohm in parallel, and then you have 8 volt, and then you need to also, like, now you cannot directly convert this into, because this 10 volt resistance, 10 volt source, it is hindering us, right? So we need to convert these two part into voltage source and a series resistance. So the series resistance is 100, that's okay, and the voltage will be from down to top, that's the polarity. It should be 30 milliampere by 100 ohm. So it should be 30 into 10 to the power minus 3 by 100 ohms, right? We are doing wrong. So actually it should be V equal to IR, right? So V equal to IR means it should be V equal to IR. So I equal to 30 into 10 to the power minus 3 times 100 volts. So you can say that it is 1, 2, 3. So it is 3 into 10 to the power minus 3 multiplied by 3 into 10 to the power 3 volts. So it is given by 3 volt. So it is 3 volt. Okay. Now you can add them up with this, and this is V0 we need to calculate across this, right? So here also V equal to IR, V equal to IR means I equal to V by R. So V equal to IR means you have I equal to V by R. So here V is 10 and R is 100, so you get 1 ohm, and the same thing is here. Okay. So now in the third circuit, you have a current source of 0.1 ampere. You can have a 0.1 ampere here and 100 ohm resistance here, and this is the target 100 ohm resistance here, which is across the V volt to be calculated, and you have a 8 volt and 3 volt connected in series, and you have 100 volts here. So I won't jump the step. So it is 100 ohm, and you have a voltage source of 11 volt, right? So here they have connected in series. Now in the fourth circuit, you can actually convert this into a current source and a parallel resistance. So this is 0.1 ampere still, and this is 100 ohm, and this is also 100 ohm, and that part is the current source, and you also have a 100, because this will be 100 ohm. So this is the V0. So this is 100 ohm. So this 100 ohm is this 100 ohm is this. Now with this transformation, this 100 ohm comes at this part. Okay. So this is 11 volt. Okay. Now this now this 11 volt. Now this is a current source. Now we cannot write V here. So what should be the current of this current source? The current of this current source will be 11 divided by 100 ampere. So it is 0.11 ampere, right? So now you have now the fifth equation. Now you can I can jump the step. So this is 0.1, this is 0.11, they are connected in the same direction. So the bigger current source will be 0.21 ampere. Now this 100 ohm and this 100 ohm, they are also connected in series, also connected in parallel. So what will be the value of the resistance? So 1 by 100 plus 1 by 100 equal to 2 by 100. So that is basically your 50 ohm resistance, and then the target resistance of 100 ohm. So which across which some current is flowing, and the voltage across this is V0, that to be calculated. Now here also we come to a very simple term that okay, we can convert this into a voltage source and a series resistance. So which is given by, you have a voltage source and a series resistance. Series resistance is simple, here will be 50 ohm and this is 100 ohm, and what will be the value of this voltage source? It should be equal to 50 times 0.21. Now 50 into 0.21 you can calculate, don't believe me. So what will be the value? The value is 50 times 0.21, it is 10.5. It is given by here, which is given by 10.5 volt. So now you have 10.5 volt connected in series, and then 100 ohm 50 ohm connected in series with this 10.5 volts of source, then another 100 volt here. So what is the current through the circuit is 10.5 divided by 50 plus 100 ampere. So you can calculate 10.5 by 150 ampere. So what will be the value? The value will be 0.07. The value is 0.07 ampere. Now this, if the current flowing through this 100 ohm resistance is 0.07 ampere, so the V0 should be IR. So I is 0.07, which is we have just calculated, times 100 in volts, which is 7. So this is pretty simpler. We have may have went a bit faster when we came to the third problem, but ultimately the trick is that you can keep on converting into voltage sources into current sources connected in parallel, then you can transform each of them from one place to the other, and then it is pretty easy. So that's the whole thing. But the only time you can actually apply voltage source to you can apply source transformation, only apply Ohm's law when you have only one, you have only one voltage source, and you can have several resistances available. So that's for all. You can keep on viewing my my videos again and again to get the clarify. And if you like my video, please press the like button, and if you are new to the channel, for getting more updates, do subscribe, and thank you for watching. Thank you for watching. Have a nice day. Bye bye.